Hi, my name is Andrew Joerger. This is my final project presentation for CS 394 Data Engineering. The goal of my project is to leverage data on electrical vehicle registrations across Washington State from the data.gov website and vehicle green scores published on greenscores.org website to produce insights on how green common vehicles are in Washington State and what the greenest counties and cities are. So I want to be able to answer questions like, what are the top 10 greenest electric vehicles registered in Washington State? What are the top 10 greenest cities and counties in Washington State? What type of electric vehicle is best for the environment? Meaning it has the highest green score or the lowest EDX score? And what fuel type has the largest green score on average? So the data sets themselves, I have two sources. The first data set I collected from data.gov. It's a data set on registered electric vehicles in Washington State. Um, and the second piece of data is from greencars.org. It lists different models of vehicle along with a what's called a green score, which is how safe it is for the environment. So the higher the green score, the better the vehicle is for the environment, the more green it is. It also has other environment related scores, such as an EDX score, which is an environmental damage index. The lower the environmental damage index, the better the vehicle is for the environment. So those are the two data sources I collected. From data.gov, it was a simple CSV read. The other from greencars.org required web scraping the data from an HTML table on the website. So like I mentioned, there were a couple of challenges here. The first challenge was that this table on greencars.org needed to be scraped from the HTML table in order to read those green score and EDX values along with all their columns. In order to do this, I used the request library and the read HTML method we learned in lecture to parse the HTML table. But that was the main challenge, was learning how to do that to get the data off that website. Um, Next step was data exploration. After the data had been downloaded from their sources and scraped, I did an initial exploration. Um, initially I saw that there were over 1,000 vehicle models listed in the greenest.org table, and important features like make, model year, green score, and fuel type. There were over 250,000 electric vehicles registered in Washington State. Important features there were the city, county, make, model, year, and electric vehicle type. One observation I noticed in both data sets is they both used make, model, and year to identify a car type. And you'll see in the future slides that these are the three fields I used since they're all the same to merge and join those two data sets together. Next step on data exploration was using plots to identify categories and relationships between features. In this first plot, you'll see a histogram used to show the distribution of green scores amongst all vehicles listed in the table on green scores, greencars.org. As you can see, it looks like a normal distribution with a mean approximately at like 45-ish for the green score. Um, Second plot, you'll see a relationship between green score and EDX, which are the two main values you can see for measuring how green a vehicle is. You can see it has a very tight, close linear relationship, but it's also a negative linear relationship as one increases, the other decreases. The point of this was just to show that if you know one metric, you know the other. So if I know green score, it's easy to calculate EDX and vice versa. So for the rest of this presentation, I'll be focusing on green score specifically, since if we know that, it's easy to know what the associated EDX value will be. Um, Continuing on, I broke the data down into different fuel types. The fuel types given were electricity, regular gasoline, premium gasoline, and then those are the three main ones, and then a little bit of diesel and mid-grade gasoline. I decided to plot the green score for the three most common fuel types. I think those three together compose like 97% of the data. You can see that electricity, the vehicles with the highest green score are electric vehicles. You can see it's the only category where green score reaches into the 70s. The other two don't reach into that. Um, and you can see also that the vehicles with the lowest green score tend to be vehicles that use premium gasoline. You can see there's some that reach into below 20. But analyzing this based on fuel type will be done further on. But this is just an initial data exploration on how fuel green scores might be broken down by fuel type. Continuing on, um, I broke down the vehicles by another category, which was what type of electric vehicle is it? This was provided on the data.gov dataset. They broke down the vehicles onto battery electric vehicles and plug-in hybrid electric vehicles. You can see approximately 80% rounding are battery electric vehicles, and 20% of the data is plug-in hybrid electric vehicles. On the right, I show the distribution of green scores, grouping by each category and plotting the histograms. In orange, you can see battery electric vehicles and plug-in electric vehicles. I'll continue to do analysis down the road, but this is again just seeing how each category might influence the green score. Continuing on, I did have to clean the data sets. In the data.gov vehicle registration dataset, there was a column called legislative district that had about 583 missing values. It was by far the column with the most missing values. Since it wasn't important to me, I decided to drop that column altogether. And after that, delete any row that had any missing data. And there was only about 35 out of about 250,000 that had a missing entry after dropping legislative columns. So not much data was lost after removing entries with missing values. Eventually, I had to merge the two data sets together so I could see the green score for each vehicle registered in Washington State. Like I said earlier, both data sets have columns dedicated to make, model, and year, and we can use these three for merging. The main challenge there was needing to make sure values are named consistently. So for example, in the greenest data set, some vehicle makers are all capitalized. You might see it as Toyota, all capitals, while other makers like Mini aren't. So they aren't consistent in how they say the name of a make. And not only is it inconsistent amongst one data set, but it was also inconsistent with the two data sets together. So a challenging step was to clean both data sets and make sure they capitalize the same way so that they can be properly matched. Also, the more challenging challenge was to account for model names being slightly different. So for example, greenest cars might call a model Prius Prime, while the vehicle registration data set might just call that model a Prius. So strictly, they aren't equal strings, but they would be considered a match. So to fix this, I did go through the greenest cars data set and rename each model to the closest model without going into the details of how that happened, but renaming each model in greenest cars data set to the closest match in the registrations data set to ensure consistency in that they could be matched together when they're supposed to be. After the join, continued on to figuring out how to load the data set into a SQL database. This is after the data had been extracted and transformed. So like I said, I cleaned, renamed the columns, modified values like the model, and merged the data sets. I decided to partition and load the data sets into my SQL. I used the pandas method factorized to generate a vehicle idea for each unique combination of make, model, and year, and add that to the data frame. Then that was important because that vehicle ID will be used as the foreign key to create table relationships. To avoid data redundancy, I partitioned the data into 5 tables. Motivation for doing this, we know normalization. One aspect of normalization is reducing data redundancy. So for example, a single vehicle consisting of a make, model, and year may have many registrations in Washington in different counties. And instead of repeating that data across rows for each registration, you can simply have that in a separate table and have that be referenced in another table. So the code below, you can see them partitioning the data into 5 different data frames and dropping duplicates. That was the first step to normalize it before putting the data into database tables. Next step was to create those tables. I decided to create 5 tables in the SQL. And you can see on the right-hand side shows the relationships. Vehicle is the main table, and it has relationships with build, environmental score, location, and rating. Vehicle ID is the foreign key in build, environmental score, location, and rating that connect them all together to vehicle. Doing this, like I said, reduce data redundancy and use the best practice of normalization. After defining the tables, I considered to populate the data tables with data. I did that by converting each row in the data frame to a tuple and using the execute many statement we learned to insert each row into the data frame, sorry, into the MySQL database. I did that for each of the 5 data frames / tables. I wanted to mention, as you can see here, going back a couple slides, vehicle ID is defined as a foreign key in each of rating, location, environmental score, and build. Considering on to the last part of this presentation, which is the SQL queries. This is what I've been working towards, was getting answers to these questions. This is the select statement, query statement I use to select the top 10 electric vehicles registered in Washington State with the highest green score. So grouping them together across registrations, calculating the average green score, and ordering by decreasing average green score. We can see that a Toyota BZ4X has the highest green score of 66. It's tied with the Solterra and Yay. On the right, you can see the top 10 electric vehicles registered in Washington, D.C., sorry, in Washington State. Secondly, top 10 counties in Washington State. I selected the county and the average green score, grouping by the county, did an inner join on environmental score so I can get in like the green score data, and inner join the location so we can have the county data. And after that, grouping by the county and ordering by decreasing environmental score, eliminating the 10, so we just have the top 10. You see that Williamson is the county with the highest average green score on 66, followed by Camden and so forth. Third SQL query, similar, just grouping the top 10 cities in Washington, D.C., Washington State with the highest green score. Just simply replacing county with city, it gives you this. Another query was figuring out which fuel types lead to the largest green score. So here I grouped by the fuel type and calculated the average green score amongst all fuel type. This required grouping vehicle with environmental score and build. And so build allows us to get the fuel type information and order by decreasing green score. You can see electricity is the fuel type with the highest green score, average green score 46.6, which is not surprising. Followed by premium gasoline. We see that diesel is the worst. Lastly, we rank electric vehicle type by green score. Or just 2 electric vehicle types like I mentioned in the beginning. And we're selecting again from vehicle, but we also interjoin on the environmental score and the build. Group it by the electric vehicle type and calculate the average green score in each group. We can see that plug-in hybrid electric vehicles had a higher average of 45, roughly 46. And those 5 queries together answer the 5 questions I initially wanted to in the beginning, seeing which counties and cities in Washington State were the greenest, which vehicles you register in Washington, D.C. Are the greenest, best for the environment, and what fuel type and electric vehicle type had the highest green score on average, is better for the environment. So that concludes my presentation for final project for CS394. Thank you for listening.